My presentation is on how forge presses forge the world. And my name is Jake Magruder. One of the forefathers of the forge presses is either James Naismith or Francois Benoit. And James Naismith is believed to be the man who invented the steam hammer and later the power-assisted fall steam hammer. And this was done for the British Royal Navy to make paddle shafts for the SS Great Britain. But his plans were put on, to the side when a new method, a new type of shafts was used instead. So his sketches never became reality. And Francois Benoit was actually the first person to make a steam-powered hammer, but he was told about the idea from his bosses, the Magruder brothers. The Magruder brothers visited Naismith in England on a business trip to learn about some manufacturing for their company, and Naismith showed them the sketches of the steam hammer, and that's how they brought the idea back to Francois Benoit. There are two types of forging, and the piece of metal that's being forged is called billets. Billets are normally in a rectangular or a cylindrical shape. And the first style of forging is open die forging. It's where two flat pieces of metal compress the billet, and the shape of the billet is really up to the skill of the individual or the team of forgemen that are working the metal with the press. And the second method is the closed die forging. And this is where we can get much more complex and nuanced shapes by squeezing the metal into all the nooks and crannies of the die. And using a series of closed dies can allow for the grain structure to be more intact, be better aligned, and it doesn't destroy the billets in the process. Much easier. The first forged hammer, besides the handheld one, was the trip hammer. It was usually mechanized by flowing water over a water wheel, and the spokes of the water wheel would turn and lift the hammer, and between the spokes the hammer would then fall back down, slamming onto the billet. And this allows the forgeman to shape the metal, but has no control over the speed or how hard the hammer hits. The next important forge press is the board drop hammer, and it gets its name from having a large piece of wood, normally made of oak or maple, running up above the ram. Where rollers would squeeze the wood and turn, lifting the ram into the air, and when you move the rollers away from the piece of wood, the ram would then fall, and by the use of gravity would smash the billet. And the weight of these rams would range between 100 pounds to 10,000 tons. And then the next advantage came from the power drop pumps, or just plain air and steam. And the only difference between the powered and the unpowered is the direction flow of the secondary addition to the piston of having not just air being pushed in to the ram piston to lift it, but also to push the piston back down, assisting gravity to create higher forces to the billet, allowing for better energy conversion, because it would be much less it'd be much more inefficient to lift heavier and heavier rams to then have gravity drop when you could just push it with gravity. And finally, the most sophisticated style of press is the hydraulic press, and this method is used in all the largest forges in the world, and it removes the free fall nature of the ram that we saw in all the previous iterations of a forge hammer. But by removing the free fall aspect, you're able to control much more of the delivery of the ram to the billet, giving much better, allowing for much smaller tolerances to produce more accurate and precise parts. And the reason America realized that we needed forge presses came from World War II. The Germans, it was discovered when Americans shot down a few German planes that there were parts in the German plane that were extremely large, so they could have only been made from a heavy press. And in this diagram, you can see that the German piece of the airplane only has 5 parts, and none of the holes had to be drilled by hand, while the American part had 18, and you had to drill holes not just for screwing in the similar 4 parts that were in the German, but also to attach all the other pieces together, which increased the labor. And part of the war reparations after World War II is that America got 3 of Germany's presses, a 5-ton and 2 15-ton presses. But the Russians got the largest press, the 30,000-ton press, and also got plans for constructing a 50-ton press. And America became worried about how much of an advantage the Russians had over America with such large presses, which would allow them to make parts for their industrial complex to be much better and more efficient and quicker. So, America started the heavy press program. The heavy press program was started to fund the construction and the manufacturing of the world's largest presses. The project created and 2 50-ton presses and 2 35-ton presses, as well as which gave America the largest presses in the world. And there was a survey conducted a few years after the heavy press program ended to determine whether or not even larger presses were needed. The United States Air Force looked into presses between 50 to 200,000 tons. And they concluded that it was not necessary, that the 2 50-ton presses would be sufficient at covering all of America's needs. But it would have been really cool to have such a large press, 200,000. The 50,000-ton press is 8 stories tall, just incredible amounts of force. But I digress. And the advantage to heavy presses can be seen in this example of looking at the spars of a F-102A. It's an American jet plane. The spars are the pieces that strut out into the wing and give it its structural integrity so it doesn't just bend and fall over. And the difference between performing the hand tooling and using a press is it reduces 600 man-hours, and it reduces the part count by 200, and eliminating thousands of rivets and connection holes that would have to be drilled by hand, which in return reduces the price of all the struts by $20,000, making the plane cheaper. And it really gave quite an advantage for these aircraft. And forging didn't just make parts cheaper as well as quicker, they were also stronger because they were all one piece and not made up of several pieces and could fail at many different connection points. And then, if I haven't sold you enough on these presses, if we look at the landing gear of a B-52, a piece of the landing gear when pressed, only has 85 pounds of wasted material. Wow, if it was created using tooling, there would be 1,300 pounds of wasted material. Thank you.